Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel. Voltaic cells. Last time we talked about electrolytic cells. We say that electrolytic cells, for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it, it is reduced. So it means that it's less reactive. It can accept the electrons. Yes. It can accept the electrons. If you are broke, it means that you can accept everything. Yes, so you oxidize others. You make others to be broke. All right. So we are saying strong oxidizing agent. It means that they can accept the what? The electrons. For them, they are reduced. So they are you put them on the cathode. They're positive. Because cathode is positive, so they are able to receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of voltaic cells. So I will say that this is a red cat. This is a red cat. This is a red cat. So don't forget that. I'll tell you what it means. All right. So we are saying red cat. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc, so there is a reaction which takes place here, and there is a reaction which takes place here. Yes, we say that zinc is more reactive. It is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity ceiling. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc. Therefore, it's going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two bakers are connected by a salt bridge. Salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that the half reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes, so it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes, you see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes, so your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes? And then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, if it forms a solid, then the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid. Yes, it means that now the solution will start to fade out. Yes, to be fading. Why? Because the copper ions which make the solution to be blue, they are being used up. Therefore, now the solution becomes pale. It fades until it becomes clear. Once it becomes clear, then it means that all the copper ions have been used. So you need to know those small concepts so that when they bring the question, you are able to answer them nicely and clearly. So, all right, let's compare. Let's compare the two half cells. Yes. Number one, zinc half cell, then copper half cell. The one we have talked about, oxidation reaction at the anode, which is always negative electrode. We know that anode is always a negative electrode. Yes. So oxidation occurs there. It means that zinc will ionize. Yes. When it ionizes, then it increases in the charge. Then obviously reduction will occur at the cathode, and it's always a positive electrode. This one is supposed to be a reducing agent because it causes this copper to be reduced. Yes? And then itself, it is oxidized. When it releases electrons, you see, it releases electron, comes from 0 to 2. So it has been oxidized, increase in the state. While this one, it has accepted. Therefore, it's a strong oxidizing agent. It has caused this one to be oxidized. And for it, it is reduced from positive 2 to 0. You see, it has been reduced. And it has caused this one to be oxidized. It is a strong oxidizing agent because it has caused this one to be oxidized, and itself it is reduced from 2 to 0. That's the meaning. Then when you go to zinc, okay, the equation, this is the equation, what is happening, we saw it nicely, and also this is what is happening, we saw it nicely. Yes. So you read from right to left. We're going to look at it when we go to the reactivity series. And then here, read from left to right. You're going to look at it when you go to the reactivity series. All right. So when you're writing the cell notations, we're going to look at it, and then you're going to get it better. All right. We are saying that zinc is a strong, zinc is the stronger reducing agent, while copper 2 is a stronger oxidizing agent. I've explained this. How is this is a strong strong oxidizing agent? Because it causes zinc to be what? To be oxidized. Then it becomes an agent for oxidizing. But itself is what? Is reduced. And then zinc is a strong reducing agent. Yeah, it is an agent for reducing. So it causes copper to be reduced. But itself is done what? Is oxidized. Then we are saying that the anode always decreases in mass if the reducing agent is solid. I've tried to explain it, that if you look at zinc, because zinc is dissolving into the solution, then the mass must be reducing as long as it is, this electrode is a solid. So it means that it keeps on reducing in size. It is corroded. Yeah, it starts to disappear. All right, and then they're saying the cathode always increase as long as it is a solid, always increase in mass if the reduced product is a solid. Yes, so we saw that since copper is a solid, if you look at it here in the equation, copper is a solid, even you can look at it here, yes, is a solid, then it means that the terminal must be increasing in size, always, as long as it is a solid. Since now you know the concept, now it means that we can apply these concepts in different versions. All right, net cell reaction. It means that we're going to combine the half equations, and then we see what we're going to form. Make sure they have equations balanced. Balance them, including the electrons. I try to show you on the equation that the electron must be balanced. Add the two half reaction together, eliminating the electrons from both sides. So that now when you add them, then you eliminate the electrons, and then it cancels out, then you form a full equation. Let's look at it. Here is oxidation, which is taking place on this side. Yes, on this side of the half cell. Zinc metal, yes, or solid, dissolves to give zinc ion plus 2 electrons. The 2 electrons, they start to move. These electrons, they will come to this side. So what happens? This one will receive. We'll receive these ones here. When they come here, and then they combine with this copper. So copper 2 ions plus 2 electrons, which came from zinc, and then you form copper solid. So this one forms a solid. It is deposited here. While this one starts to dissolve, which is this, dissolves and then becomes small. becomes small, becomes big. Husband and wife, one must be becoming smaller, one must be becoming bigger. All right, let's continue. I don't know what is happening in your family. If your father is becoming small or your mother is becoming small, then one must be oxidizing agent, another one must be a reducing agent. All right. Maybe you are the one, you kids, who are making them to be oxidized. Or to be oxidized. Yeah, or to be reduced. Whatsoever, I don't know. All right. Net cell reaction. So now how do we form? You have reaction which is taking place here, reaction which is taking place here. So arrange them like this and then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid. I leave it. I go to copper ions this side. Yes. Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this side. I have zinc 2 ions. Do I have zinc 2 ions? No, I leave them. I have copper 2 solid. Copper solid. Do I have copper solid this side? No, so I leave them. So now I combine zinc plus copper 2. Zinc plus copper 2. This is a solid. This is aqueous. Always, whenever you have a charge, it is aqueous. You should just have to know that. Then the arrow, yes. And then I have zinc 2 aqueous plus copper solid. These ones, they cancel it. That's how you can write the full equation. Simple. Know what is the anode, what is the cathode. Find the equation there. One must be reduced, one must be oxidized. Find the equation, write the equation down, then combine them. Simple. No stress. Then, salt bridge. Part of an electrochemical cell. It's usually a tube. It's usually a tube. It can be containing electrolyte, providing electrical contact between the 2 solutions. So we are saying that it's a part of electrochemical cell. Yes, usually it's a tube. It means that the chemicals are being put into the tube. Containing an electrical contact. It must be containing an electrolyte. It must be containing an electrolyte. It means that it can. The substances you have put there, it must be able to conduct electricity and it should be able to release the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number 1, to complete the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number 2, it keeps the 2 electrolytes in the 2 half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these 2 must be neutralized. If they are not neutralized, then it means that the cells will be impaired. The cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell so that the ions are neutralized so that the cell can continue working or functioning normally. All right. Number 3 is allows movement of ions between the 2 electrolytes from the cathode cell and then the anode cell. The 2 must be able to communicate with one another, even if there is a distance. So the salt bridge connect them. Note, electrolyte in the salt bridge must contain ions which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question.